Good evening, boys and girls, and welcome to your video tonight. Tonight we're going to discuss Chapter 9.2, Electricity and Magnets. Now the reason that these two terms are together in our video is because magnets and electricity are very similar, and we're going to spend the rest of today's lesson discussing why they're similar and talking about some of their similar features. Alright, go ahead and grab your Science Interactive Notebook. You're going to have 3 essential questions tonight to write down. Remember to either leave space for the answers in between, or I know a lot of my students like to write it on the next page. Either one's fine. So again, go ahead and write down your essential questions. The first one is, what happens when you bring the poles of magnets together? Number 2 is, how can magnets be created? And number 3, what can electric motors do to electricity? So again, go ahead and write those 3 questions down. Either leave room to the same page or put your answers on another sheet. Alright, let's go ahead and get started with our first word. Our first definition of the night is pole. And a pole is part of a magnet where magnetic force is concentrated. Now this word concentrated means where most of it is kept. So again, a pole is a part of a magnet where magnetic force is concentrated or most of the force is kept. Now I do want to point out the poles on our magnets that you see in front of you tonight. This is the North Pole and this is the South Pole. Now, very rarely will you see poles labeled on any kind of magnet. Like if you just look at the magnets in our classroom, turn on the back, it does have a south and a north pole, but they're very rarely going to be labeled. You can also find magnets that are not necessarily shaped like the one on the screen, but you can find ones that's shaped like rectangular. We have circle ones in our classroom. We have some that kind of have the clip on it. They have magnets on the back. They're all very similar, and all magnets will have a north and have a south pole. So go ahead and jot down this definition, and if you'd like to, go ahead and label the north and the south pole of your magnet. Now magnets can react 2 different ways towards each other. The first way a magnet can act is to attract. Attract means to pull towards itself. And if you take a look at this magnet here, you'll notice that these poles are not alike. This is a south pole, this is a north pole. Therefore, they are attracting to each other. All right, again, this is north and a south pole. So 2 unlike poles. 2 unlike poles always attract to each other. And I forgot to mention on the last slide, but I do want to tell you guys that the magnetic force around here, around the poles, is where the magnetic force is the strongest. So go ahead and keep that in mind. And another way magnets can react to each other is to repel. Repel simply means to push away. Now on the last slide, if you remember, I told you that opposite sides, opposite poles of magnets attract. So I do want to point out that because we know these 2 magnets are repelling, these 2 magnets are being pushed away from each other, then I know, okay, if this is a north pole, then this must be a north pole. If these 2 are north, these 2 must be south. So because these are like poles, they're going to repel or push each other away. And because these are 2 like poles, they're going to do the exact same thing. And next up is the word magnetic field. Magnetic field is a region of magnetic force around a magnet. Now, if you take a look at this magnet here, it's just a regular magnet laid down. You see the north and you see the south pole, and somebody has sprinkled magnetic pieces around this magnet. And as you can see, it gives you a ginormous magnetic force, so you can see how strong the poles are. If you take a look at the north and the south poles, most of those magnetic pieces are there because that's where the strongest current is going to be in your magnet. Again, to the right, another example, and as you see north and south, those poles are where the strongest force is going to be in your magnet. Now, if you've ever wondered how a compass works, I'm here to let you know. So the Earth is one ginormous magnetic field because the inside of the Earth, the iron core, like we've talked about before when we talked about layers of the Earth, that is all magnetic. So therefore, a compass is a big magnet. So whenever you're walking and trying to figure out which way you're going or driving, your compass allows you to do that because your compass is always pointing north. So depending upon which way you turn, it will tell you exactly which way you're going because the Earth is a magnetic field. Therefore, that's how the magnet and a compass works. All right, our next word tonight is electromagnet. Electromagnet is a temporary magnet created when current flows through a wire wrapped with coils around an iron bar. Now, there are several different types of electromagnets, but one that pops into my mind is if you're in construction, I see them all the time driving down the road. I see big electromagnets that are able to move steel bars when doing construction. So because of this big job, these electromagnets need to turn on, and they need to be able to turn off just as quickly as they turned on. Therefore, that's when electromagnets come in hand. So if I work in a construction area and I want to pick up this big steel bar, I can turn on my electromagnet and pick it up and move it wherever I want. Well, as soon as I get it in position, I need to be able to turn that electromagnet off and drop my steel bar where I need that to be. So that's the good thing about electromagnets, is they're only temporary, that they only last a certain amount of time. These magnets can be easily turned off as soon as you turn off a button or as soon as you let them go. Now, I do need you to do me a favor, okay? I have a question for you, and I want you to look at both of these models down here on the bottom of your page, both of these models. Essentially, they're about the same, but there's one thing that's different about them. And the one thing that's different about them is how tight the coils are wrapped around. Okay, this one here on the left-hand side, we're going to call that one A. All right, and I see A, it's not wrapped very tightly at all. Okay, it's kind of loose here. And then let's look at B. B is pretty tightly wrapped here. So I need to ask you a question. My question is, which of these, either A or B, which of these is stronger? Okay, now again, go ahead and jot it down in your interactive notebook and maybe a reason why, and we're going to go over it in class tomorrow. Again, you're not going to get this wrong or right. It's not going to be for a grade. I just want to see if you know and if you can tell me why. Is A stronger or is B stronger? Again, which one of these magnets or electromagnets is stronger and why? All right, and the last word of tonight is electric motor. Electric motor is something that we use every day, and it's a device that transforms electrical energy into movement. So think about your washing machine, think about a motor in the car. Those are all electrical motors. All right, in tonight's lesson, we've looked over 3 important questions. The first question we asked is what happens when you bring the poles of magnets together? We learned 2 things may happen. One, that the poles can come together or attract, and like poles or magnets repel, opposite poles attract. We also learned how magnets can be created. One way magnets can be created is by using electric current. These are called electromagnets. And our last essential question, what can electric motors do to electricity? Electric motors can change energy into motion and then power those things that we love and use every single day. All right, boys and girls, well, that wraps it up for tonight. Before class tomorrow, please make sure all Instagrams are done. Hashtags, definitions, sentences, pictures, words, all should be legible. Legible means just being able to be read. So make sure you're writing nice and neat for us. Your lesson essential questions and your answers, those should all be done. Also, please remember to have the answer A or B to the question asked in the slide about electromagnets. Now, we're not going to count it incorrect if you didn't get what we got, but I just want to make sure that you're thinking of it so we can go over it tomorrow in class. Again, if you have any questions, please let us know tomorrow in class, and I'll see everybody tomorrow. Have a good evening.